Hello, in this video we're going to be talking about Chapter 1, Section 4, which is in Simplifying Algebraic Expressions. There's two skills that should have been covered in your Algebra 1 class that we're going to review here, and I'm going to be straight up honest. This is bugging me that we're doing this by doing a video because I love teaching this. I love explaining this part because it goes to one of the main things that drives me as a teacher, and that's explaining why we do things, why things work, not just how does it work. This idea, you probably learned it like this. Cover that up right there. You probably learned PEMDAS. And you see PEMDAS everywhere, and actually Dr. Berger, the guy who wrote your book, calls it PEMDAS. I am not a fan of tricks. I am not a fan of just do this and it works. Why does it work? I don't know. It's magic. It just works. I see this a lot with different ways people explain things in math, and it's one of my rants that I go off on, and I know I'm hilarious. But this is just a perfect example of times that students have been taught something, and I feel, in my professional opinion, that the way it was taught was wrong. Okay? So I'm going to try to explain why this works before we actually do the three examples. Like I said, you probably know PEMDAS, which is parentheses, then exponents, then multiply, divide, add, subtract. And you said, this is the order that I need to do stuff. So I need to do exponents before I add, or I need to multiply before I subtract. Well, without an understanding of what this really means, then it causes problems. And this is one of those things where people will send me math problems that are floating around social media like Facebook, and they'll say, can you explain why this happens? Yeah, it's because your math teacher didn't teach you the order of operations correctly. You actually start down here, okay? Not in the order you do problems, but you start here to understand it. What is adding, okay? I don't know if your teachers ever asked you that. What do you mean by adding? We learned how to add way back in kindergarten, but did you ever think about, well, what is the purpose of adding? Well, adding is this. 3 plus 5. If I say 3 plus 5, I get 8. I can count all these dots and get 8. But what am I really doing here? I've already counted these 3 dots. That's 3. I've already counted these 5 dots. I get 5. Add 3 plus 5, I get 8. All I'm doing is saving myself the step of starting over counting. So if I had 3 dots and I had 5 dots, I want to know how many I have. I could go 1, 2, 3, 4, 5, 6, 7, 8. So adding is just a shortcut for counting. That's all that it is. You've already counted something. You've already counted something else. If I add those two things together, it's just a shortcut so you don't have to start over and count from the beginning. Now, subtraction is a little tricky. Mathematically speaking, there is no subtraction. Subtraction doesn't really exist in algebra. And I'm sure that maybe some of your math-learned friends and relatives are probably going, what? Turn that off. Hold on, let me explain. Subtraction doesn't really exist because if I said, let's say 7 subtract 4, yeah, that means if I've got 7 dots, 1, 2, 3, 4, 5, 6, 7, and I'm going to take away 4, how many do I have? But see, in algebra, that's really not what's happening. In algebra, this actually means 7 plus the number negative 4. So we say subtraction is actually adding the opposite. The opposite of 4 is negative 4. So subtraction, yeah, it does really, it's a thing, but algebraically, it's completely redundant. So we can get rid of it. We don't need it. And when I teach Algebra 1, I really work really hard to get the students to realize that change all your subtraction problems to addition, adding the opposite. And it helps when we do problems like this. What's 11 subtract negative 7? People freak out over that one. Subtraction is adding the opposite. So this is 11 plus the opposite of negative 7 is positive 7. All right? And that's really some upper level math involving groups and rings that a lot of teachers don't really get into. Okay, they don't really explain that. So the next level would be multiplying and dividing. Well, what actually is multiplying? Okay, so if I had 4 plus 4 plus 4 plus 4 plus 4, see how I'm repeatedly adding the same number over and over again? Well, how many times do I see a 4? Well, there's 5 of them. So this is what we would say, 5 times 4. Now, a couple things. We're not going to use that symbol anymore. So we're either going to use this or we're going to use parentheses. Parentheses are kind of like the workhorse. They do a lot of things. And also, this was another thing that people send me on social media. There was like a parent that was posted that he or she was upset because a student got a problem wrong. Okay, so we say, and I don't know if this is the example, but the choices were this was A, and this is 4 times 5. So which one of these represents that? And the kid had chose that and got it marked wrong. And the parent went to Facebook to complain instead of just asking the teacher, which is what I would hope someone would do. What got left out of the conversation was, this is not 4 5s, it's 5 4s. They both equal 20. Or in an earlier video I said, the equal sign causes problems. That's a problem that we have here. They both have the value of 40, but they mean different things. 4 times 5 would be 5 plus 5 plus 5 plus 5. 4 5s, or 5 4 times. So we get into this type of discussion about what multiplying is, all right? But remember, multiplying is just a shortcut for adding, and adding is just a shortcut for counting. So everything is still just counting. What's dividing? Well, dividing, like subtraction, is redundant. We don't really need it. So if I said, what's 12 divided by 2? This symbol right here is called an obolus. All right? It's actually, some people say it looks like a fraction, the top divided by the bottom, because I can also write this like this, 12 divided by 2. All right? We are going to try to avoid the obolus as much as possible. Later, there's going to be one section that we're going to kind of have to use it, because otherwise just the way we write stuff is going to be really, really messy. But we're going to try to avoid the obolus as much as possible. As a matter of fact, the International System of Math and Science has banned the obolus, and it causes all kinds of order of operation problems. Okay? So if I do write it as a fraction, 12 divided by 2, that's the same as 1/2 of 12. And that of actually means multiplying. So dividing means multiplying by, and here's a word you remember, the reciprocal. I hope that your elementary teacher never used the phrase keep, change, flip. I hate that. You're multiplying by the reciprocal. Both the opposite here, -7, and the reciprocal here, both of those are related to an idea that's very, very important in math called inverses. 7 and -7 are called additive inverses. 2 and 1/2 are called multiplicative inverses. 7 plus -7 equals 0, which is the additive identity. 2 times 1/2 equals 1, which is the multiplicative identity. I spend so much time in class explaining that because it's simple ideas. Notice I'm just multiplying and adding single-digit stuff except for the 12. But there's some high-level concepts in this math. And all of this is stuff that, unfortunately, most of you aren't going to see until you get to college. But I'm not going to lie to you. I'm going to give you the truth. That brings us to the E if you do Pemdas, or the E and the R if I do exponents and radicals, or if I do Pemdas, sorry. Exponents, and I'm running out of room over here, exponents are repeated multiplication. So if I say 2 times 2 times 2 times 2 times 2, that's 2 to the 5th power. Remember that multiplying is just repeated addition, and addition is just counting. So all of this is just counting, all of it. I'm not going to have time to talk about the associative property, because one of the things you learn when you do order of operations is you're supposed to work from left to right. That's not always necessary. And I won't go into detail, but I'll just give you an example of what I'm talking about. 2 plus 5 plus 3. Add the left to right. 2 plus 5 is 7. 7 plus 3 equals 10. But also 2 plus 8 is 10. And 5 plus 5, 2 plus 3 equals 5, is also 10. So the associative property says it doesn't matter which order you start in. Same thing with multiplying. One of the reasons why we try to we try to avoid subtraction and dividing is because it doesn't work using the associative property or a commutative property. What about radicals or square roots? Later in this class, we will show you that radicals can be written as an exponent. All right, that's one of the topics we will be covering. So I will bring up this conversation later. Okay, this video is starting to get a little long, so let me finish it up. How do I evaluate? Most people just say substitute. And when I teach this in the Algebra 1, I go, yeah, just substitute and plug in the number and follow the order of operations. And I get blank stares. So I broke this down. You're going to copy the expression exactly as it's given. Don't be careful copying it. You're going to put parentheses around the variable, and since you're using a pencil, I'm using a Sharpie, you're going to erase the variable, and you're going to put inside the empty parentheses the value that you're going to use, and then you do the order of operations. And if you can do that, you can survive most physics and other science classes that involve formulas when you go to college. That's what got me through Physics 152. All right, so let's do a couple problems here real quick. I have x plus 3xy, 3 times x times y, subtract 2 times y. I'm going to replace the x with a 4 and replace the y with a 7. Now, like I said, I'm using a Sharpie, not a pencil. If I used a pencil, I would do the copy, parentheses, erase, and replace. So I'm going to pretend that I copied and put parentheses around all of the variables. Now, that's an x, that's an x, that's a y, that's a y. So now I'm going to replace the x's with 4's. So I put a 4 here and I put a 4 here, and I replace the y's with 7. Now I do order of operations. I'm going to first multiply in here and over here. 3 times 4 is 12, and 12 times 7 is 70 plus 14, which is 84. So I got 4 plus 84. 2 times 7 is 14, so I'm going to subtract 14. Now, this is where the working left to right, it's going to be okay for this particular problem, but if I had a different problem, I'm just going to jot something down here real quick. If I had 10 subtract 5 plus 2, one thing that people do is they say, okay, order of operations is Pemdas or Pemdas, adding comes before subtracting. So they say this is 10 subtract 7, which equals 3, and that is wrong. Okay? Remember, subtraction is adding the opposite. So for a problem like this, it'd be 10 plus negative 5 plus 2. And in that case, I could do 10 plus 2, which is 12, and the real simplified form over here would be 7. Over here, because it's adding on the left and then subtracting, it should be okay. You're probably not going to run into that mistake, but please get into a habit of 4 plus 84 plus negative 14. I'll put it in parentheses to help out. And then you can add it in any order you want. 4 plus negative 14 is negative 10, and this is just 84 take away 10. Or you could say 84 subtract 14 is 70, and 70 plus 4 is 74. Whichever order you want to do because of the associative property. I'll do the next ones pretty quick because they got exponents. So I've got b squared times z minus 2 times b times z plus z squared. Yeah, that's really, with the Sharpie, it's really confusing. So my b is 6, my z is 2, bz, so that's 6 times 2, and z squared, that's my 2 squared. Okay, so I'm going to take care of all the exponents first. I'm going to do 36 times 2, subtract 2 times 6 times 2, plus 4. 36 times 2 is 72. 2 times 6 is 12. 12 times 2 is 24, plus 4. All right, so now this is the problem I was talking about. Add first. 24 plus 4, I get 28. 72 minus 28 is going to give me the wrong answer. Because these things all happen at the same time. Adding and subtracting happen at the same time. And I know we get into a little, well, just do it left or right. No. This is 72 plus negative 24 plus 4. Now, add these two, then that. Add these two, then that. Or add these two and that. Whatever is easiest you can do in your head. For me, I'm going to do 72 plus 4 is 76, plus negative 24, and that's going to give me, I think, 52. And if you do it any other way, negative 24 plus 4 is negative 20, 72 plus negative 20 is 52 again. And what's the other one? Oh, 72 plus negative 24, what would that be? 48, and then 48 plus 4 still gives you 52. So they all work. I get x squared y minus x times y squared plus 3 times y. My x is 2, so 2 goes here and 2 goes here. My y is 5, so I got 5 here, 5 here, and 5 here. Let's scoot that up so you can see it. Exponents first. 4 times 5 minus 2 times 25 plus 3 times 5. 4 times 5 is 20. 2 times 25 is 50. 3 times 5 is 15. That's the same as 20 plus negative 50 plus 15. And again, I need to emphasize this over and over again. If you're getting help from like somebody else explaining this, I just need you and everyone else helping you to understand. It's not about getting the answer. It's about understanding the language of algebra so that we can then attack different problems. So again, I know that this seems like perhaps we're making things really complicated. It's not about making it complicated. It's about getting you to be fluent in the language of mathematics. I like how I should write that down. I just came up with that. Okay, however, if I do these two together, I get negative 30 plus 15. If I do these two, I get 35 plus negative 50. And if I do these two, I get 20 plus negative 35. All right? I'm going to add the two positives together, do 35 plus negative 50, and that should be negative 15. All right, in the next video, I'm going to do more of these type of problems.